Okay, so today I generated an audio cloner using Google Colab, and so the thing is that I used specifically this voice to clone and it played so that you can get to know what that voice was. Okay, so this was the voice I was like using to clone, and the output was this. Okay, so as you can see, the voice was like perfectly cloned, and how I did that is by like using code from I generated this code using Gemini and a GitHub repo. I'll like mention that link in my description. And I used Colab because I needed a GPU, and in Colab we can have a GPU T4 for free. And the thing is that we need to manually switch it on every 12 hours, and the window of that Colab notebook should be open whenever we are like trying to generate the audios. So that is the manual part right now for free tier. But if you want to go like totally automated, you can have that. Like you can buy a GPU same with same like specifications as T4, and you can have this whole automation setup. And the time it took to generate this audio was around like 40 to 45 minutes, and the script it generated um, an audio for was this. And as you can see, it was a long script having like around 16 chapters with intro and outro, so that were like around 10,000 words. So it was a massive script to generate. And what it did is that in this automation, I first of all fetched the documents whole data, and then I like uh, passed it through a code node to like split those into different items. Like if it's intro, it will be a single item, and the file name will be intro.wav. So .wav is the extension for audio, and then chapter 1, chapter 2, and all, and so on. And then like I generated this loop so that the HTTP node gets one item at once and doesn't get like confused or exhausted on like on the fire of all items at once. So I generated the loop so that it circles around one item at once and it goes on. So using that, it generated the audio, and the time it took to generate an audio, like an average audio, was around 2 minutes and 15 seconds. As you can see, 128 seconds, and then 125, 189, and 132. And that was like because of this GPU specifically. So it was like totally free. It didn't cost me anything, not even a penny. But the output is here. Like as you can see, I've already like played it. So I guess I need to play something else maybe so that you can better get to know about the audios. Okay, okay, so as you can see, the audio is like perfectly tuned to what I wanted to clone it for against, and uh, it was like if it's about like how I can scale it from 1 to 5, I'll be scaling it to at least 4 because it was very perfectly cloned and had a great uh, similarity between those voices which I wanted to clone and the voice it generated. And yep, there is a thing, I should say, a wait time for like around 5 minutes, because I need to like download the model, which is which will be like shown in the script. I'll be like sharing it with you. So that's the time. I can like even skip that time as well. um, it was specifically from Coqui AI. It was an XTTS model, so I can skip that time by like downloading that whole setup in my Google Drive. And uh, will like, first of all, it will gonna, on my first run it will gonna take 5 minutes, but then after that, it whenever I'll be like generating audios again, it will gonna take like at max 30 seconds to like get the whole model out from Google Drive, and we're gonna use that in Colab. But I don't want it to do that specifically, because that would have cost me storage on my Google Drive. And for free, if it works like cost me around 5 minutes to wait for a while, then why should not? So thanks for watching, and this was it.
Following the initial hushed reports, further details regarding the immense stone structures in Gornaya Shoria began to surface through unofficial channels. Or perhaps had never ceased operation. One particularly alarming report, dated late 2012, highlighted seismologists and high-resolution satellite imagery. They meticulously mapped the precise locations and time